Welcome to our journey through the cosmos, where we'll explore some of the most extreme weather conditions in our universe. Imagine a place where diamonds fall from the sky like rain, or where winds rage at thousands of miles per hour. We're not talking about science fiction, but real phenomena happening right now on other planets and moons. From diamond rain to winds that could blow you away, literally, let's dive into the wonders of space weather. Our first stop takes us to the outer reaches of our solar system, to the ice giants Neptune and Uranus. These planets, often shrouded in mystery, hold a dazzling secret: they rain diamonds. Now, you might imagine a gentle sprinkle of sparkling gems, but the reality is far more dramatic. Deep within the atmospheres of Neptune and Uranus, the pressure is immense, millions of times that of Earth's atmosphere. The temperature also soars, reaching thousands of degrees. Under these extreme conditions, something extraordinary happens to a common element: carbon. The immense pressure squeezes the carbon atoms together, forcing them to bond in a tight tetrahedral structure. This structure is the very essence of a diamond, the hardest known natural material. As these diamond crystals form, they become heavy and begin to fall towards the planet's core. Imagine a cascade of diamonds, larger than any found on Earth, plummeting through a dense, turbulent atmosphere. This is diamond rain on Neptune and Uranus. While we haven't directly observed this phenomenon, sophisticated computer simulations, based on our understanding of physics and chemistry, strongly suggest its existence. These simulations take into account the extreme pressures and temperatures, along with the behavior of carbon under such conditions, painting a vivid picture of this extraordinary weather event. The diamonds, formed in the heart of these ice giants, may eventually settle into a solid layer around the planet's core, a treasure trove hidden beneath thousands of miles of thick atmosphere. The sheer scale of this diamond rain is mind-boggling. Scientists estimate that over billions of years, trillions of tons of diamonds may have formed within Neptune and Uranus. These planets, once thought to be cold and barren, are now revealed to harbor unimaginable riches, albeit riches we are unlikely to ever possess. The study of diamond rain on Neptune and Uranus not only expands our understanding of these distant worlds, but also provides valuable insights into the behavior of matter under extreme conditions that are difficult to replicate even in the most advanced laboratories on Earth. Now hold on to your hats as we journey to a place where the wind makes a hurricane look like a gentle breeze. Our destination, HD 189733b, a gas giant exoplanet located about 63 light-years from Earth in the constellation Vulpecula. This planet, slightly larger than Jupiter, orbits its star at an incredibly close distance, making it a scorching hot Jupiter. Imagine winds whipping around the planet at speeds of up to 5,000 miles per hour, that's 7 times the speed of sound. These winds are so powerful that they can circle the entire planet in just over 2 hours. The star-facing side is a scorching 1,700 degrees Fahrenheit, while the dark side is a relatively cooler 970 degrees Fahrenheit. This massive temperature gradient fuels the planet's powerful winds. The cooler air from the night side rushes in to fill the void, generating winds that whip around the planet at supersonic speeds. Chapter 3. Our cosmic journey now takes us to our nearest planetary neighbor, Venus, a planet often described as Earth's evil twin. While Venus shares similarities with Earth in size and composition, its atmosphere is a stark contrast, a hellish realm of toxic clouds and scorching temperatures. And if you thought acid rain on Earth was bad, Venus takes it to a whole new level. Imagine a planet perpetually shrouded in thick yellowish clouds, not of water vapor but of sulfuric acid, one of the most corrosive substances known. These clouds, extending up to 50 miles above the surface, trap heat, creating a runaway greenhouse effect that sends temperatures soaring to an unbearable 900 degrees Fahrenheit, hot enough to melt lead. But the real terror lies in the rain. High in the Venusian atmosphere, sulfuric acid droplets condense, forming a corrosive downpour. However, this rain never reaches the surface. As it falls through the superheated lower atmosphere, the sulfuric acid droplets evaporate before they hit the ground, only to rise again in a continuous cycle of infernal precipitation. This constant rain of sulfuric acid, combined with the extreme temperatures and crushing atmospheric pressure, makes Venus one of the most inhospitable places in our solar system. The surface of Venus is a desolate wasteland, scarred by volcanoes and vast plains of solidified lava. The thick atmosphere traps heat so effectively that the temperature remains relatively constant day and night across the entire planet. Landing on Venus is a feat of engineering, with spacecraft facing extreme heat, pressure, and corrosive rain. Only a handful of missions have successfully landed on Venus, and even those were short-lived, succumbing to the planet's harsh environment. Despite its hellish conditions, Venus holds valuable lessons for us here on Earth. Its runaway greenhouse effect serves as a stark warning of what can happen when greenhouse gases are allowed to accumulate unchecked in a planet's atmosphere. Studying Venus helps us understand the delicate balance of our own planet's climate and the importance of protecting it from the dangers of unchecked climate change. Chapter 4. Our next destination takes us to a world that's both familiar and alien: Titan, Saturn's largest moon. Titan is unique in our solar system, possessing a dense atmosphere, a rarity for a moon. But what makes Titan truly remarkable is its surface, adorned with lakes and rivers, not of water, but of liquid methane. Imagine a world where methane, a gas on Earth, flows like water, carving channels, forming lakes, and even raining from the sky. This is Titan, a world of frigid beauty and alien wonder. Titan's atmosphere, composed primarily of nitrogen, is thicker than Earth's, creating a surface pressure about 50% higher than our own. However, the temperature on Titan is a frigid minus 290 degrees Fahrenheit, far too cold for liquid water to exist. Instead, methane, a simple hydrocarbon, takes on the role of water, existing in all three states: solid, liquid, and gas. Titan's methane cycle is similar to Earth's water cycle, with methane evaporating from lakes, forming clouds, and raining back down on the surface. The lakes and seas on Titan are vast, some larger than the Great Lakes of North America. These bodies of liquid methane are thought to be incredibly deep, potentially hundreds of feet deep in some areas. The shorelines of these methane lakes are dotted with what appear to be river deltas, evidence of liquid methane flowing across the surface, eroding the landscape and depositing sediments. Titan's methane lakes are not only a spectacle to behold, but also hold clues to the moon's past and potential for life. While life as we know it cannot exist in Titan's frigid methane lakes, scientists speculate that other forms of life, adapted to these extreme conditions, might be possible. These hypothetical life forms, dubbed methanogens, could utilize methane as a source of energy, much like Earth-based life forms utilize oxygen. The search for life on Titan, even in its most basic forms, is a tantalizing prospect, pushing the boundaries of our understanding of life's possibilities in the universe. Chapter 5. Our final stop takes us to a planet often associated with dust Mars, the Red Planet. While Mars is known for its rusty red hue, caused by iron oxide or rust on its surface, it's the planet's dust storms that truly capture the imagination. Imagine a wall of dust, hundreds of feet high, engulfing everything in its path, turning day into night and blanketing the landscape in a thick layer of red dust. This is a Martian dust storm, a phenomenon so powerful it can engulf the entire planet. Mars is a dry, dusty place with a thin atmosphere that's about 100 times thinner than Earth's. This thin atmosphere, combined with the planet's low gravity, allows dust particles to be easily lifted into the air, even by relatively gentle winds. Once aloft, these dust particles absorb sunlight, warming the surrounding air and creating updrafts. These updrafts lift more dust into the air, creating a feedback loop that can quickly escalate into a massive dust storm. Martian dust storms can grow to immense sizes, sometimes covering the entire planet in a thick haze. These global dust storms can last for months, blocking out sunlight, cooling the surface, and significantly altering the planet's climate. The dust particles themselves are incredibly fine, much smaller than a grain of sand, and can remain suspended in the atmosphere for long periods, giving the Martian sky its characteristic pinkish hue. While Martian dust storms are a natural part of the planet's climate cycle, they pose a significant challenge for future human exploration. The dust can damage equipment, reduce visibility, and even pose a health risk to astronauts. Understanding these dust storms is crucial for developing strategies to mitigate their impact and ensure the safety of future Martian explorers. Despite the challenges they pose, Martian dust storms are a testament to the power of nature, even on a planet with a thin atmosphere and relatively weak winds. They remind us that even in the vastness of space, weather can be a powerful force, shaping landscapes and influencing the course of exploration. Thanks for joining us on this incredible journey through the cosmos. We've witnessed diamond rain on Neptune and Uranus, braved the supersonic winds of HD 189733b, weathered the sulfuric acid rain on Venus, sailed the methane lakes of Titan, and weathered the dust storms of Mars. The universe is full of wonders, and we've only just scratched the surface. Don't forget to like, subscribe, and hit the bell icon for more fascinating space content. Until next time, keep looking up.